Okay, so for addition and subtraction, we're going to combine like terms. Like terms are same variables with same exponents. And then with subtraction, you need to change the signs first. Change the signs, and then treat it like an addition problem. Now, you might not just want to throw that arrow up there. That might not make sense to you as you look at your notes. I'm just saying, once you change the signs, then you treat it like it's an addition problem. Multiplication is the distributive property. Some of you enjoy using the box method for multiplication, and I'm okay with that. And then division, we have two methods that we learned. We learned long division, and we learned the box method for division. And I think most of us enjoy the box method more than we enjoy long division. Do you remember your order of operations? Candace, please excuse my dear Aunt Sally, whatever you guys use to know that multiplication, division comes first, and then addition, subtraction. Yep. So for this question, number one, where you see, I see a multiplication, I see a subtraction, and I see a division. I hope you see that as well. What would you do first? I would do the multiplication here, and then I would have to do the division here, and then do subtraction. That's your order of operations, right? So you got you and your partner. One of you picked multiplication, the other one picked division. Pick your favorite operation. One of you do the first part, the other one do the second part, and then we'll do subtraction together. Don't fight over them. It's a long year. I'm not positive on those answers. I copied students' work. A little bit of plagiarism going on here, but I'm allowed to do that. If you disagree, let me know so we don't mess this baby up. Is that what you had? Awesome. Did you have a good weekend? Yeah, good. Awesome. Yeah. Okay, so from that point then you're going to change the signs here, distribute your negative sign through, and then combine your like terms. I see x squared, it's at plus 11x minus 22. Agreed? Awesome. All right, and that's how you're going to do your order of operations. And finally, this is a little bit easier. The directions are, all we need to do is figure out what the first term and the last terms are. We don't have to do the whole problem. Okay, we can figure out the first term, which would have the highest exponent. So I see a 2x to the third here, and I see a negative 6x to the third here, and we're adding those together. So the first term is going to be negative 4x to the third. I don't have to worry about anything else. That's the highest exponent, that's the first term. The last term is the constant. I have a 7 and a negative 9. Combine those together, and it would be negative 2. And so that's all we have to do is get the first term and the last term. Does everyone know Mrs. Herrick? She's never quiet unless I'm wearing this. And she's quiet. Yes, it is. It is on right now, though.
Yay.
We are recording. You know Mrs. Herrick. Now we got to get the first term here. All we have to do is the first term. So x times 2x, and then times x again. And so the first term would be 2x to the third. And then the last term's a constant. All we have to do is worry about the numbers there. Negative 3 times 3 is negative 9, times negative 1 is a positive 9. The last term would be 9. Why are you frowning at my work? It's okay? All right. Okay, so here we have a multiplication problem, and here we have a multiplication problem. Those would come first with order of operations. 2x times 3x is 6x squared. But when I come over here and I do x times 2x squared, I get 2x to the third. So this part, I didn't even have to do, did I? And because this is subtraction, that would actually be a negative 2x to the third, because I'd be subtracting it when I did the problem. And now for the constant, over here I'd have negative 3 times 5, which is a negative 15. Over here my constant would be 1 times 3, which is 3. But again, it's a subtraction problem. And negative 15 minus 3 would be a negative 18. And the last term would be negative 18. Questions? Speak freely. And then for D, the first term, we have x times 3x, which is 3x squared. Over here, if you're going to square x minus 4, it would be x minus 4 times x minus 4, which means you would have an x squared term there, which you'd have to subtract, and the first term would be 2x squared. And now we talk about the constant. The constant here would be 5 times negative 1, which is a negative 5. Over here, you'd have a negative 4 times a negative 4, which is a positive 16. But again, it's a subtraction problem. So my last term would be negative 21. So the first term, last term thing, if you want to do the whole problem and to get the answer, you can. I just think you'd be wasting some time there. Okay, so for number 3, again, they only want you to figure out the first term and the last term, just like we just did this. The ... means the pattern continues. In other words, it's m plus 1 times m plus 2 times m plus 3 times m plus 4 times m plus 5 times m plus 6. But they got lazy and didn't want to write all that stuff out, so they put 3 dots. Yes. So the first term would be n times n times n times n, which would be n to the 10th. The last term would be 1 times 2 times 3 times 4 times 5 times 6 all the way up to 10. And that's actually factorial. Have you ever done factorial? You take your calculator, 10 times 9 times 8 times 7 times 6 all the way down to 1 is 10 factorial. Go 10, math, probability, that's the exclamation mark. And that would be 10 times 9 times 8 times 7 all the way down to 1. Have you done that before? Okay, don't worry about it. We'll do it later this year. But that's a quick way of doing that. Or you just take your calculator and multiply it out, right? And that would be your last term. Okay, for part B, if you did x minus 2 to the 10th power, x minus 2 times x minus 2 all the way 10 times, what would the first term be? X to the 10th power, right? And then your last term would be negative 2 times negative 2 times negative 2 to the 10th power. So if you're going to do that on your calculator, make sure you have parentheses around your negative 2 before you take it to the 10th power, because I believe it should be a positive answer. But if you don't put those parentheses down, you get a negative answer. and then you lose sleep at night. For part C, if you worked this all the way out, the first term would be x to the 10th, but then you divide that by x minus 2, your first term would be x to the 9th. Okay, that's not the way to do the division, but we don't have to do the division. They only want the first and the last term. So we just have to use common sense on that baby. And then over here, you'd have negative 2 to the 10th as your last term, but you'd be dividing by a negative 2, because that's the last term there. And so the answer would be negative 2 to the 9th. And then finally, this one here, your numerator would be n times 2n, 2n to the 3rd over 6, because there's a 6 in the denominator. And the last term would be 1 times 1 over 6. So the first and last term thing, that should be a little bit easier for you. Hopefully save some time. And then the homework is 1 through 6.